Party time. Must be time for a new question. All right. This question is going to be about finding a tangent. So, what are the steps for tangents questions? It is find point of intersection, which is typically by substitution. Intersection. Struggling on this whiteboard. Then we find derivative function. Maybe we substitute to find, okay, the value of slope. Typically f dash of a. Then we use the equation of tangent. I will try to leave this on the side here. Not sure how we'll go. It's f dash of a. This is going to be a number, x. I want this to be an x. Here's the original x part of the point of contact and the y part of the point of the contact. F dash of a is slope. This is height on the graph. Okay, y equals 2 ln x4. First of all, what is the exact value? We have graphics calculators. We can make lots of shortcuts, but the word exact means we don't want a shortcut. Okay, y-intercept, y-intercept. So this is knowledge. The y-intercept is when x equals to 0, you're going to substitute it in. Y equals 2 ln 0 plus 4 equals 2 ln 4. We can look for this on the calculator. Just looking around for one. Okay, look for this on the calculator. We'll get this as a nice decimal. But for this question, this is precisely what is meant by the term exact. At the end of the question, the end of the problem, I'm going to be adding that number right here. This is equal to f of 0. Well, it might not be. We'll see what's going on. I think it's x equals 1 is the point that we'll go there. Okay, you'll have to dance for a little while I find a calculator. Okay, now looking at part B of this question. Looking at part B of this question, what is that value when y equals 0? Now, what's got to, instead of have y equals 2 ln x plus 4, this is a little bit of algebra practice. What happens when y equals to 0? And solve for x. Okay, so first of all, let's divide by the 2. And how do we remove, what are we going to do about this ln? I'm going to take e both sides, or raise both sides to the power of e. Now, 0 divided by 2 is 0. So put this to the power of e. And e to the 0 is, I hope everybody remembers that it's 1. We'll write this down here. E to the 0 equals 1. ln of 1 equals 0. Formula sheet for everybody. Okay, so e to the 0 equals 1. E to the ln equals whatever's in the bracket. Or x equals minus 3. So, what's the purpose of these two questions here? This is a simple substitution. So really the first purpose is, do you understand the y-intercept? For the second part, it is basically coming down to this step here. Can you solve backwards through an ln or an e question, exponential question, to get the x out of the bracket or out of the exponent if it was an e question? Okay, continue with our ln question. So now we're looking for making a sketch of this function. So we'll see whether or not this comes up on the computer. So I'm of course into the graphics calculator. I'm going to type in the equation 2 ln, quite liberal use of brackets. This is always where x is. And draw. Okay. Now, who knows what's been going on with this calculator recently, so I'm going to go to View Initial and Draw. Okay, so I probably need to just zoom out one time. Right, now I do believe that we've already worked out that this point over here is -3 from the previous question. So let's draw something coming along here. So here's the basic shape. Now we understand this doesn't actually have a horizontal asymptote. So this is a y in this case. Question said y. X, we worked out that this was -3. There's not going to be too many points of interest. So let's have a look at what this point is on the calculator. Now from previous question, I think that was 2ln4. Just having a look here. Yep, that's right at that. Let's just have a look, see what it is as a decimal on the calculator. G-solve, y-intercept, 2.77. Okay. All right, highlighting key features. Well, the only two key features on this graph are the x-intercept and the y-intercept, and there is a vertical asymptote for ln graphs that are to the left. Now, a little bit of thing. Normally, this vertical asymptote would be x equals 0, but this graph has x plus 4. So it's been shifted 4 to the side. So this vertical asymptote is x equals -4. If you're not able to gather that, you would of course be maybe doing a trace on your graphics calculator, which I hope you can see. And we see that we get to x equals -4 and we get an error because we've hit the asymptote. Okay, so that's sort of what we're looking for key features. Very quickly, we're going to go into finding the tangent. Okay, so up here, and we'll have in the corner a little sketch of that graph that looked a bit like this, and we're looking for a tangent when x equals 1. All right, so that's what we're looking for. We're looking for the equation for that dotted line. What are the steps? All right, find the point of x a equals 1. What is f of a? It equals 2ln 1 plus 4 equals 2ln 5. First step. Next one, find f dash. If y equals 2ln x plus 4, then the derivative equals 2 times by 1 over x plus 4 times by the derivative of the inside part, which is just 1, equals 2 on x plus 4. So the slope, well, that's that. Second step, f dash of a. When x equals 1 equals 2 on 1 plus 4 equals 2 on 5. Final step. For the tangent. Now we're looking to complete and write the equation of the tangent. So y equals f dash of a times x minus a plus f of a. So in this case, here's the derivative once we have substituted x equals to 1. So 2/5 bracket x subtract 1. A equals 1 in this question. Plus f of 1. Now f of 1 is what we went and found at the start. F of 1 to ln 5. Now I would prefer to have the equation in the form y equals mx plus c. So let's multiply that out. 2/5 times x, subtract 2/5 plus 2 ln 5. So this part here actually is the c. And that's the equation of a tangent. Find the equation of the tangent to this curve when x equals 1.